There are three types of exponential word problems that we're going to talk about today. There's appreciation, depreciation, compound interest, and half-life doubling and tripling time. Okay, so here is the first exponential word problem. It's the appreciation, depreciation word problem. So if something appreciates, you take 100% of what it was and you add the increased interest rate. Okay, if something depreciates, you take 100% of what it was and you subtract what it's depreciating by. So what we'll be left with will be how much interest is left in the RESP, the car, anything like that, okay? The formula we use for appreciation is F equals I bracket, that's a 1. People are always like, what do I put in the 1 spot? It's a 1 plus I to the power of n. F stands for final value. I put that down here so you can see it. F stands for final value. I stands for initial value. 1 plus the interest rate in decimal form, and your n is your number of years. The only difference for depreciation is you still have final, you have initial, you have the 1, but you're now going to have your interest rate in decimal form, but your interest rate in decimal form is going to be a minus. Oops, I did not put that. This needs to be a minus. That's a typo. I'll fix it in your notes before I post it. So you will have minus signs here. It needs to be a minus because you're subtracting the interest rate from 1. So there's your difference. And then number of years. In your notes, those will be minus signs because I'll fix it before I post it. All right. So we're going to go through, just like in physics, I think in chemistry, and you write your known values. And you can only be missing one known value, okay? Which would be called your unknown. So we have the initial price of the car is $3,000. So I know my I, capital I, is $3,000. That's my initial. It's what it came off the lot at. The value of the car depreciates. Oops, so I know I'm going to be using the depreciation formula. It depreciates by 20% per year. Well, I know the little I is my interest rate, but it has to be in decimal form. So I take my 20%, I divide it by 100, and I get 0.20. If the car is new in 2005, how much will it be worth in 2010? So from 2005 to 2010 is 5 years. So that's my n. And it wants to know what it's going to be worth. So it wants to know the final. Okay? So we're going to plug it into the depreciation formula, which is final, which is F, equals initial, which is 3,000 in this case, bracket 1 minus 0.20 to the 5, the power of 5, exponent. F equals 30,000. Fix your bracket, so 1 minus 0.20 is 0.80 to the 5. And now when you don't know what F is, that's the easiest one to find because you just type this into your calculator right here. 30,000 bracket 0.80 to the 5. And remember, to get that exponent to the 5, you have to use the little hat symbol. And so F equals 9,830.40. Okay? So what would you have to do? You'd say the value, because we always write sentences because it's a word problem. The value, oh my goodness, of the car in 2010 is 9,830.40. Okay? So we just need to find our important information. All right. Let's read highlight this time. The initial price of the car is $50,000. The value of the car depreciates, again, we're going down, by 10% per year. How long, so it's asking us for time, to the nearest year will it take for the car to be worth at least half of its original? at least half of its original. So its final is going to have to be at least half. So we can take our half of it. All right. So capital I initial is 50,000. We know it depreciates, so we're going to have to use the subtraction. 1. And the interest rate is 10% per year, but we need it in decimal form always, so we do 10% divided by 100, and you get 0.10. How long will it take? We're looking for n, for the car to be worth at least half, so the final value to be half of 50,000. How do we do half of 50,000? We just do 50,000 times a half, or 50,000 divided by 2. So our final is going to be 25,000. Oh, there's this one part of my iPad where it does not let me write on it. It's so crazy. Okay, so we have to use the subtraction formula. So we're going to go 25,000 equals initial, which is 50,000, bracket 1 minus interest, so 0.10 to the n. So we don't know what n is. Our first step is going to be to put that bracket together. So I'm going to get 25,000 equals 50,000. 1 minus 0.10 is 0.90 to the n. Our next step is always, if we're looking for n or we're looking for I, our next step is always to divide that initial over. And the reason why we can divide the initial over is because the initial and final both don't have any variables. So I'm going to divide that 50,000 over. And so what I end up getting when I divide that 50,000 over is 0.5 equals 0.90 to the n. And once you divide the initial over, you can y1, y2 it. So I have 0.5, so we can do it with our calculator like I taught you in the last lesson. 0.90 to the n. So we're going to go y1. Oh my goodness, it's a disaster. y1, y2, and then we do second trace 5, enter, 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 which I taught you in the last lesson. So if you didn't watch the last lesson or you don't remember, I'll write the steps once here. Second trace 5, which is intersect. And I like being able to have my calculator on my whiteboard or my smartboard for you guys, but I don't have it with me. Second trace 5 intersect, enter 3 times. So we're going to go enter, enter, enter. Okay? Should go times, so you don't put a time symbol. Enter 3 times. And then you'll get n equals, so you take the x value always. When you find the intersection point, you always just take the x value, and the x value is 6.578, etc. And then you have to look for what I asked for rounding. So I said to the nearest tenth of a year. That's the important part for my last step. So I always go back and look, okay, what did I ask for rounding? Oh, nearest tenth. 10 has 1 0, so that's 1 decimal place. I always remember how many decimal places by how many zeros the number has. So if it's the nearest tenth of a year, a 10 has 1 0, so 1 decimal place. Nearest hundredth, 100 is 2 zeros, so 2 decimal places. Okay, so we need 1 decimal place. So it's going to be n equals, take the 5, look next, it's a 7, so 5 is going to go up to a 6. So 6, I'm in the dead zone of the iPad, 6.6 years. Okay, so it takes 6.6 years for this car to be at least half of its original value. Okay, next question. The population of a city was 250,000. Now this is the key thing. You have to look at the year that goes with it to find out if it's initial or final. And keep reading. The population of the city was 250,000 on January 1st, 2000. and 310,000 on January 1st, 2008. So 2008 is later than 2000. So 250,000 is my initial, and 310,000 is my final. If the growth rate of the city can be modeled by an exponential growth function, so that means it's increasing or appreciating, the average annual growth rate of the population of the city, to the nearest tenth of a percent is. Okay, so they want I. They want the little interest because they want the average rate of growth or average interest increase. So I need to have n because I can't be missing two things. How do I get n? Oh, 2000 to 2008. N is 8. Okay, let's fill it in. So final is 310,000 equals 250,000, my initial. 1 plus little I to the 8. And the first thing I do, like I said, is I divide that initial over. So I divide the 250,000 over. And I'm going to get 1.24. 1.24 equals 1 plus I to the 8. And then we can just y1, y2 after we've divided our initial over. So our y1 and our y2. So our y1 would equal 1.24. Our y2 is going to equal 1 plus x to the 8 because we don't have a little I, right? So we're going to do x. And then we find out where they intersect. Sorry about that. So what we're going to do is we're going to try and find the x of the intersection point. When we find the x of the intersection point, it gives us x equals 0.027. Now people are like, oh my goodness, that's way too small. Well, it's not. It's the interest rate. It's I in decimal form. So what do I need to do with that answer? I need to multiply it by 100. And so I get 2.7%. So it says, what's the average annual growth rate of the population of the city? The average annual growth rate of the population of the city from 2000 to 2008 is 2.7%. Always have a statement. Oops. On the previous question, I forgot to write a sentence. Bad on me. So the sentence for the example before would be, how long will it take to the nearest tenth of the year for the car to be at least half of its value? I should have had a sentence that said, it will take 6.6 years for the car to be worth at least half of its original value. Sorry, I should have had a sentence up there. All right. So that's appreciation and depreciation. Then we move on to compound interest. Compound interest has the formula F equals I bracket 1 plus I divided by CP n times CP. Well, what the heck do all those things stand for? Well, F is still final amount, I is still initial, capital I is still initial amount, 1 is still a 1, I is still interest rate in decimal form, N is still number of years, but CP is the compounding periods. Now what a compounding period is for example, if I put, I did not mean to make that flip, sorry. If I put, let's say $1,000 into a bank account, okay? And it earns 10% interest. And it compounds monthly. What that means is I put my $1,000 in, and at the end of the month, because it compounds every month, I take the interest that I've earned on that $1,000. It gets put into the account with the $1,000, and then it compounds. So the next month, I'm making money off of my $1,000 and my interest. Okay, and then at the end of the second month, it takes the interest off of that I've made off of my $1,000 and my interest from the first month, and it compounds it into there again. So every month, if you have it compounding, you're actually making interest off your previous month's interest. So your investment will grow faster. So you want it to compound more when you're investing money, when you're trying to make money. For mortgages, you're paying, so you want it to compound less. And in Alberta, it compounds every 6 months. So your interest that your mortgage has made technically for them gets put in, and now you're going to pay interest off of the money, the principal you put in, and the interest. Okay, so compounding periods just means how many times that it's going to compound per year. So if it says compounds monthly, if you look at this little chart, it gives you the numbers. Compounds monthly, that's 12 times a year. Compounds quarterly, that's every quarter, like every season. So that's 4 times a year. Semi-annually is 2 times a year, and annually is 1. So we have to look for that compounding period. So the difference between appreciation formula and the compound interest formula is just dividing by that CP and multiplying by that CP. So we have to look for that little bit extra information. How we know it's a compound interest word problem? It has the word compounded in it. It's like the easiest giveaway word problem because it has the word compounded in it. Okay, highlighter. And remember, the final amount is the initial amount plus the interest earned. So if they just want the interest, or they just give you the interest, you have to add it to the initial amount to get your final. Okay, example. Sam invested $500, so he invested $500 initially in an account that paid 6% per annum. Per annum just means per year. Don't let that throw you off. It's always going to be written like that. Compounded, boom, compound interest formula, because it has the word compounded. Compounded semi-annually. Determine the amount of interest, so how much interest was earned in 5 years to the nearest whole dollar. Okay, let's write down what we know. So Sam invested $500, so that's my I, capital I, my initial value. At 6%, so that's my interest rate, but my interest rate's always in decimal form, so I have to divide it by 100, so I get 0.06. Compounded semi-annually, so that's 2 times a year, so CP is 2. And the chart up there tells you. Determine the amount of interest earned in 5 years. So we know N is 5. So the only thing we don't know is F. So even if we weren't sure what it was asking us to find, the only thing we're missing is F. So we're going to have to find it. So we have F equals, didn't need to do bracket, 500 times 1 plus 0.06 divided by 2, CP, and then 5 times 2. So I get 500, bracket 1. So I go 0.06 divided by 2 first in my calculator. Then I add 1. So I get 1.03 to the exponent 10. And when I type that, so I'm going to go 1.03 to the exponent 10, and then times it by 500. I get F equals 672. And people will tell me that's the interest earned, but it's not. It's not the interest earned. So I asked you for the amount of interest earned, so how much extra he made. The final value is what you walk out of the bank with. So you walked out of the bank with $672, but you walked into the bank with 500. So the interest earned was 672 minus 500 because you had taken the 500 in initially. So the interest you earned was actually $172, not the whole 672. 672 is what you walk out of the bank with. So we write ourselves a sentence and we put, I'll do it in a different color, the amount of interest earned in 5 years is $172. Okay. Next example. $7,000 is invested in a 6-year GIC. We don't really care about GICs, but GICs are little saving plans you can go into. So $7,000, 6 years, compounded quarterly, so we know we need to use the compound interest formula, at a rate of 5% per annum. Remember, per annum is just per year, not to throw you off. Determine the value of the investment at the end of the term. So now I want the value of the investment, not the interest, but the value. So I actually do want F this time. So I is 7,000 is invested. 6 years, so N is 6. Compounded quarterly, that's 4 times a year, so CP is 4. Rate of 5%, so little I is 5 divided by 100, which is 0.05. Determine the value at the end of the year, at the end of the term, capital F. So I have F equals 7,000, bracket, 1 plus 0.05 divided by 6, and then divided by 4, compounding periods, not 6, divided by 4, because it's divided by CP, and then N, which is 6, times CP, which is 4. So I actually get 7,000, and then 0.05 divided by 4 plus 1 is 1.0125 to the 24. If I go 1.0125 to the 24 times 7,000, my final value is 9,431.46. And that's including the 7,000 I went in with. But it wants to know at the end of the term, what is my investment worth, not what the interest is. So that is what the answer is. So I say the value of the investment at the end of 6 years. A little spot on my iPad. The end of 6 years is $9,431.46. Okay, we have one more compound interest question. Find the interest rate, okay, this time they're asking us for little I, to 1 decimal place, at which a $3,000 investment, so what you went in with, compounds quarterly, which is 4 times a year, will double in value over 5 years. Okay, let's break that down. Find the interest rate, so we want little I, so I better have everything else, in which a $3,000 investment, so my capital I is 3,000, compounded quarterly, my CP is 4, doubles in value, so my final is doubles the 3,000, so I do 3,000 times 2, which is 6,000, over a period of 5 years, so my N is 5. And we're good, because the only thing I'm missing is a little I, and I fill in my formula. 6,000 equals 3,000, bracket 1 plus I divided by 4. It doesn't look like a 4 at all. It's a little better. And then N times 4. So what did I tell you to do? Divide over that 3,000, that initial. So if I have my final and my initial in all of these word problems, that's the first thing I'm going to do is divide it over. So I get 2 equals 1 plus I divided by 4 to the 20. And then I told you once you divide your initial over, you can y1, y2. So this will be my y1. This will be my y2. So y1 would equal 2. And y2 is going to equal, in brackets, 1 plus bracket x divided by 4, and you have to put it in brackets so that your calculator knows it's a fraction, to the power of 20. And then you go second trace 5, math enter, enter, and I, or x in this case, because you always take the x of the intersection, is 0.141, but it wants it to 1 decimal place. So I'm going to times it by 100, and I get 14.1%. And then I have to write my sentence, which is the interest rate per annum is 14.1%. Okay, we have one last type of word problem left. It's a doubling, tripling half-life. How do you know you have to do this type of question? Is it'll say it doubles or triples in this time, or how long does it take to double, triple, or half? It's often like a radioactive material if it's halving, or bacteria of some sort if it's increasing, or doubling or tripling. Okay, the formula is somewhat similar. You have F equals I, R to the T over P. F is still final, I is still initial, R is the rate. So over here it shows you the rate in this box. If it's doubling, R will be 2. If it's tripling, R will be 3. If it's halving, R will be a half, which makes sense because if it's doing nothing, R would be 1. So if it's doubling, we're going to take 1 and we're going to times it by 2, so the rate would be 2. If it's tripling, we're going to take 1 and we're going to multiply it by 3, so the rate would be 3. If it's halving, we take 1 and we take half of it, which is a half. So that's why your R values are 2, 3, and a half. The hard part is for people to understand the T and the P. The T is time to reach final. So if it says, in 10 years, I have 3 bacteria, which is kind of crazy. In 10 years, I have 3 bacteria, then the time to reach final would be 10. So T is how long it takes to get to the end. If they say, in 60 years, I have 1 million bacteria, my final would be 1 million, and my T would be 60. P is the period. So it's how long it takes to double, triple, or half. So if it says it halves the radioactive material halves every 30 minutes, then the period will be 30. So if the time follows half doubling or tripling, the word half doubling or tripling, then the time is often your period. Okay? The key is that the time and the period, time to final and period, have to be in the same units of measurement. So like hours, minutes, whatever. All right, let's try one out. Okay, a lab tech placed a bacterial cell. What does that tell me? That the initial, a capital I, is 1. Okay. It placed a bacterial cell in a vial at 5 a.m. Good to know. The cell divides in such a way that the number of cells doubles every 4 minutes. So it's doubling every 4. So if I can say every 4, it's doubling. So in 4 minutes, I have 2. And in 4 minutes, I have 8. And in 4 minutes, I have 16. And in 4 minutes, I have 32. If I can say that that's every 4 minutes, it's doubling, then that's my P. Okay? If it's the time that you take in between each doubling period, that's your P. So also if it follows after the word doubling or tripling or half, I told you it's often your P. So it doubles, so R is 2. Every 4 minutes, so the period is every 4 minutes. It does this, it doubles, doubles, doubles. How long does it take for the cells to divide? How long does it take for the cells to divide to produce 4,096 cells? So they gave you the final. Oops, I'm still in highlighter. They gave you the final, which is 4,096, and it wants to know how long it takes to reach final. So they're asking you for the little t. So let's fill it in. Final, 4,096, equals initial, which is 1, rate, which is 2, t over p, t over 4. Sorry, I had this frog in my throat from all of the last podcast and this one. It's awesome. I apologize. Okay, my first step I told you to do was divide by your initial. So we're going to divide that 1 over, which is really not going to do anything. So we have 4,096 equals 2 to the t over 4. And then we can y1, y2, or we can do common base as well, like we did in the last lesson. So we can y1, y2. The key thing to this y1, y2, though, is I have y1 is at 4,096. So I have a horizontal line at 4,096 on the y. If your y maximum is at 10, you're not seeing that horizontal line. So whatever your y1 is on all these word problems, your y max needs to be at least that. So you'd go into your window and you'd have to make your y max be 4,096. Okay? Sorry, my daughter came in to grab clothes. So we have y1 equals 4,096. Your y2 is going to be 2 to the power of x divided by 4. Okay? And then second trace 5, math, enter, enter. And your x value, which in this case is your t value, equals 48. And what unit is it? Well, you look at at P's units. P's units are minutes. So this is minutes. Does it make sense? In 48 minutes, there are 4,096 bacteria. It makes sense. 1 second.
Thank you.
You're welcome. This is what teaching at home is like. My daughter came in to grab some clothes, and the only quiet place was in their room, so to do this podcast. So sorry about that. So we're at 48 minutes. All right. So we have to write ourselves a sentence. It takes 48 minutes for the cells to divide to produce 4,096 cells. So we don't want to just write, it takes 48 minutes. That's not a good sentence, and that doesn't explain anything. Okay? We need to write a full sentence. 2 more examples. And then we're done. A culture starts at 3,000 bacteria. So I know my initial is 3,000. After 3 hours, now we have to decide, is this T or P? So we have to keep reading. After 3 hours, the estimated count is 48,000 bacteria. Is the word double, triple, or half-life anywhere near that 3 hours? No, so there's a good chance that that's the T. Let's see. After 3 hours, there's 48,000 bacteria. Is that time to reach final? Yes, so it's T. So we were right. So T equals 3 hours. And final equals 48,000. Now we need to either have R or P. It says, what is the doubling period? Well, it gave us doubling, so we know our R is 2. And it's asking for the doubling period, so it's asking us for P. Whenever the word doubling, tripling, or half is in your question, it's often asking you for P. Okay, let's fill it in. So we get 48,000 equals 3,000, bracket 2 to the 3 over P. What's the first step I told you to do each time? Divide over your initial. So divide that 3,000 over. So I get 16 equals 2 to the 3 over P. And then I can y1, y2 again. Ooh, highlight for everyone who knows me, all my kids in my classes. sidetracking right now, but it's super exciting because we've been waiting for so long. We, as including you guys, because I've been telling you about it for forever. We got our possession date yesterday for our house. It is June 5th. Everyone be super excited for me. I'm super pumped. I get to get out of the basement suite. Isn't that amazing? For those of you who don't know me, I've been stuck in a basement suite since October as our house is being built because our other house sold in like 6 days. So we've been out since October in a basement suite with my 2 daughters and my husband. And June 5th, we get our house. It got delayed because of other things, and then it got delayed because of COVID. But June 5th, I get to be in my house. Isn't that awesome? I know. Maybe you don't think it is, but dude, I'm super pumped. Okay, back to the question. So y1 equals 16, and y2 equals 2 to the power of 3 divided by p. Okay, and we do second trace 5, math enter, and we get, instead of a p, it would be an x, because you're going to be like, where the heck's the p on the calculator? Which you could use, but x is just easier. All right, so we look at the x as the intersection, second trace 5, math enter, and we get our x equals 0.75, or 3/4 of an hour. So it took 3/4 of an hour to double, to go from 3,000 to 6,000 to 6,000 to 12,000. So every 3/4 of an hour, this bacteria is doubling. We need to write ourselves a sentence. Oh, are you doing that? Oh no, I did not. I was so excited I didn't leave hardly any room to write a sentence. Okay, the doubling period. And then I put myself on the dead zone of my calculator, or my iPad. The doubling period for the culture of bacteria is 3/4 of an hour. All right. Last example of the week. Exciting, right? Almost as exciting as my house, but not. All right. What is the half-life of plutonium-232? 232 is just an isotope. Don't try and put 232 somewhere in the question. What is the half-life? So we know they gave us R as a half. Of plutonium-232, if in 204 minutes, so that's at the time to reach final, and they want the half-life period, so they want P, the sample decayed to 1/64 of its original. So this is the hardest question you can be given, and it throws people off all the time. So they want 1/64 of its original. The key thing here is the original amount and the final amount aren't given, but the final is 1/64 of the original. So you can make the original be whatever you want and the final be, what is 1/64 of it. Okay? So I always make my original be 1. 1, whatever. If they give me the choice and they say it's 1/64 of my original, I make my initial be 1. And then I make my final be 1/64 of 1, which is 1/64. Because that's the easiest way to do these ones. So my final is 1/64. And it equals my initial, which is 1. And then I have half to the t, which is 204 over p. Okay? What did I tell you the first step is? Divide by my initial, and my initial is 1. So life was good because it just stays the same. So I get 1/64 equals 1/2. No, come back. 1/2 to the 204 over p. Now for all of these, you actually could have solved by common base and not used y1, y2, but it doesn't matter. I will accept either at this point. So if I go into my y1 and I put 1 over 64, and I put into my y2 1/2 to the power of 204 divided by x, I'm going to find out where they intersect. And it is at 1 second. My calculator is being silly. I have to make my X max bigger, because whenever I have problems, it's always my X max. I need to make my X max bigger. So I get X equals 34, or P equals 34. Please make sure you put fractions in brackets. So when you go to put any of these in your calculator into your y1, y2, put them in brackets. So it's 34 minutes. So what does that mean? That means that this plutonium-232, not sure why I didn't capitalize that, pretend it's capitalized, because it's the beginning of a sentence. Plutonium-232 has a half-life of 34 minutes. And that is it, and that is all for you for today. I hope you enjoyed it, and I hope you have a wonderful weekend after you have finished your math for this week. And also, I just want to tell you again, because I don't think you remember, I miss you. Doing these podcasts this way with your child interrupting you to get pants and such is not nearly as fun as having you in class. So I miss you all.